In section 8.5, we're looking at quadratic functions. And so a quadratic function is a function of the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. When graphing quadratic functions of the form f of x equals ax squared plus bx plus c, the first thing you're going to do is find the coordinates of the vertex, which is negative b over 2a, and then plugging it back into the function to find the y. You're going to find the y-intercept is at f of 0. The x-intercepts, if they exist, occur where f of x equals 0. They can always be found with the quadratic formula, and sometimes they can be found by factoring. So let's look at example number 1. We want to find the vertex and the intercepts. So that's the x and the y-intercept if they are there. Let's do the vertex first. What we need to find the vertex is our a, b, and c. So our a is 1, our b is negative 8, and c is 15. So to find the vertex, first we look for x, which is negative b over 2a. So we have negative 8 all over 2 times 1, but the double negative becomes a positive 8 on the top with a 2 on the bottom, which just gives me 4. So what we want to do now is plug 4 into the function. So we're looking for f of 4. That's 4 squared minus 8 times 4 plus 15. And so this gives me 16 minus 32 plus 15, which is going to give me negative 1. So our vertex is the point 4, negative 1. Now let's go ahead and find the y-intercepts. That's f of 0. So we have 0 squared minus 8 times 0 plus 15, which just gives me 15. So our y-intercept is at the point 0, 15. And we're also looking for the x-intercepts, if they exist. So that's when we set the equation equal to 0. So x squared minus 8x plus 15 equals 0. This can be factored as x minus 5 times x minus 3. So setting each piece equal to 0, we get x minus 5 equals 0, and x minus 3 equals 0. And so adding 5 to both sides, we get that x equals 5. And adding 3 to both sides, we get that x equals 3. And so we end up getting the points 5, 0, and 3, 0 as our x-intercepts. Let's go ahead and do the same thing with example number 2, but we're also going to graph it when we're done. So we have f of x equals negative 2x squared plus 4x minus 3. So a is negative 2, b is 4, and c is negative 3. So let's go ahead and start with the vertex. We have x equals negative b over 2a. So that's negative 4 divided by 2 times negative 2. So we end up with negative 4 divided by negative 4, which just gives me 1. And so now I'm going to plug 1 into our function. So that's negative 2 times 1 squared plus 4 times 1 minus 3. So we get negative 2 times 1, which is just negative 2, plus 4 minus 3, which gives me negative 1. So my vertex is at the point 1, negative 1. Let's go ahead and find the y-intercept next. 2 times 0 squared plus 4 times 0 minus 3. And this is just going to give me negative 3. So we end up at the point 0, negative 3. And we need to find the x-intercepts. And so that's when we set the equation equal to 0. So we have negative 2x squared plus 4x plus 3 equals 0. Now I cannot factor this, but we can use the quadratic formula to solve this. And so plugging this in, we end up with negative 4 plus or minus the square root of 4 squared minus 4 times all over 2a, or 2 times negative 2. And so we want to simplify underneath the radical. So we have negative 4 plus or minus. When I simplify this, I do end up getting negative 8. But that's going to become an imaginary number, which we cannot plot on our graph. So this means that there are no x-intercepts. So let's go ahead and plot our points that we do have. We have our vertex at 1, negative 1. We have our y-intercept at 0, negative 3. And so the shape of a parabola is always going to have an axis of symmetry down the vertex so that it mirrors this axis of symmetry. So we can also plot the point 2, negative 3, because it needs to mirror the one on the opposite side. And from here we can go ahead and just draw a rough shape of what our graph is going to look like. And so this is just an idea of what it would look like.